Assalamualaikum warahmatullahi wabarakatuh. My name is Tengku Damia Atiqah from Pra-USM Class F. In this video, me and my group member Fikri Aiman will present to you our IoT prototype project with Arduino entitled Smart Disinfex, a collision avoiding device. Collision avoidance system, or also known as pre-crash system or collision mitigation system, is a safety system used in vehicles. It is designed to reduce severe collision and accidents, especially in automated vehicles. Collision avoidance system plays a role in detecting an imminent crash and provide warnings or perform an act of prevention, such as reducing the speed or brake automatically to avoid the crash from happening. Until today, various technologies and sensors used in this system, including radar, LiDAR, which is light detection and ranging, cameras, and proximity sensors to avoid approaching crashes. COVID-19, a pandemic that changes this world 360 degrees. On today's date, we live in a total new norm where the experience of learning, shopping, doing sports, and other daily activities were totally different compared to back then. Many authorities strive towards contactless services to reduce the probability of contact between people to reduce the risk of infection. We have also seen the sacrifices from our frontliners in fighting this microbial war. They deal with this virus every day. The process of sanitizing the public places is compulsory to do in order to keep the environment clean from the virus, but it is a challenging task and uses a large number of workforce. It also drains the cost in hiring workers, PPE gears, and chemical disinfectant. Concerning their safety, we need to create a new contactless way to sanitize the public places, which is more effective, time and cost saving, and also uses less human workforce. Therefore, we would like to come out with a solution that can bring positive outcomes that can aid in the procedure of disinfection of public places. We present to you Smart Disinfex, a device designed to sanitize public places with minor surveillance and maintenance from human. Throughout this project, we are ambitious to achieve the goals we set from this innovation of Smart Disinfex. One of the goals are to reduce the number of frontliners and human force used to sanitize public places. We are very concerned about the risk of infection that most of our frontliners face each day when performing their duties. They are exposed to this invisible discrete enemy that exists on any surface carried by any person or even spread widely in our breathing air. Smart Disinfex can help them by reducing the contact between them with other people to lower the risk of infection. Sanitizing procedure will always drain the government money as it needs a huge budget, especially in hiring the workers, chemical disinfectant, and PPE gears for our frontliners. The budget is high, but on another side, we can lower it by identifying and reducing unnecessary wastages. With Smart Disinfex, it assists in upgrading the disinfection procedure from manually to intelligently automated. When using an automated system, it will be significantly cost-saving in terms of chemical usage. The fixed amount of chemical disinfectant in each spray will reduce the chances of overspraying the disinfectants, thus causing wastage for unnecessary amount of the chemical. Next, by using the proximity sensor on Smart Disinfex, we can reduce the probability of damage and increase the durability. This device needs to be utilized in a long period, depending on the area that needs to be disinfected. To To sustain its quality and performance, we need to control its mobility so that it will not collide with obstacles unintendedly. The remote monitoring can be implemented by installing proximity sensors, hence, it is easier to monitor the movement of this device from afar because it will automatically avoid any obstacle in its way. The operation of this device will be human independent and less surveillance is needed throughout the disinfection procedure.
I'm Fikri. I will continue with the working process, the outcome, and the limitation. For the working process, in the first week, we had discussed and brainstormed our ideas for this project and made a draft about the context of this project that we choose, which is collision avoiding device. We did some research on some devices that are beneficial to us and about the mechanism that applying in the principle of collision avoidance in it. After we gained our ideas and context about this smart disinfect, we proposed this idea to our lecturer and asked for some advice. We proceed on more research to explore more on its details such as mechanism, methods to build the prototypes, material use, and appropriate coding lines. After much exploration and research in the preparation of this project, we started the process of development in the same week. I started to develop the coding. We collected some coding lines from some of the references in Google. We simplified the coding lines to match our preferences and function of our prototype. We bought all of our material needed for the prototype from the Citron Technologies and the suggestion from our lecturer. To make it convenient, we bought the obstacle avoiding mobile robot kit that comes with a complete set so that we can build up our prototype without any missing parts. Next, in second week, as our coding line has developed and after several tests using this Maker Uno, we proceed with the installation of the circuit. I followed the tutorial on how to put up the mobile robot kit and attach our Maker Uno to the kit. To evaluate its ability to function as desired, we did some tests to ensure it worked well according to the coding lines. At the first attempt, it did not work well and few modifications needed to be done in our coding lines and the wiring in our circuit. There were some errors detected in the coding lines and the connection of wire in our circuit. We were glad that after a few fixing processes, our prototype functioned and worked well. On the third week, we noticed that the output of our prototype is not sufficient to show our objectives, so we added some extra component to our prototype, which is LED light. Next, there is a problem, which is we do not have any servo included in our kit to control the motion of the sensor. That result in limited range of our sensing. We are supposed to use the servo so that the sensor can sense the obstacles on its left and right, but instead, we decide to change our coding to make it function without a servo and would like to do improvement in the future. Then, on the fourth week, this week we did some final touch to our prototype and enhance its appearance by doing some designing onto its structure to make it look as close as possible to our interpretation.
Now, we will proceed with the demonstration video. As you can see, this prototype will stop when the sensor detected obstacles ranging 75 cm in front of it and will reverse before changing its route. Due to limited time, we are not able to install the spraying system for the chemical disinfectant on our prototype, so we replace the output with an LED to indicate the spraying of chemical disinfectant.
So here we can see the outcome, which using this smart disinfect, we can lower the workforce needed to sanitize public places such as supermarkets, bus stations and other functional buildings. This is due to the automation system used in this device that enable the device to function with minor monitoring by humans. Next, the process of disinfection can be done in a shorter time. This is because increase the efficiency of the workflows allow us to identify the redundant, unnecessary process and cut them out. Furthermore, the device will last longer with the implementation of collision avoidance system. This system is set so that the sensor will detect obstacles 75 centimeter away and will change the direction to avoid the collision. In addition, this will lower the cost needed as we are using this device to transferring this job from human to automated system. Furthermore, when using an automated system, it will be significantly cost saving in terms of chemical usage. The fixed amount of chemical disinfectant in each spray will reduce the chances of overspraying the disinfectant, thus causing wastage for unnecessary amount of the chemical. We move to the next agenda, which is about the limitation of this project. Firstly, we do not equip the space to put the chemical disinfectant storage kits is limited and may not fit, or it will be overloaded, resulting in difficulties to move around. Secondly, our area and routes of the movement of the prototype is not specified. Furthermore, our current prototype can only do the disinfection procedure on the lower area because the higher area is not reachable. This is due to the structure of this machine that limited its movement and the coverage for spraying the chemical disinfectant.
To cope with these limitations, we plan to add a servo to our sensors to control the motion of our sensor or use a bigger sensor. This is to increase the range of sensing so that our prototype will be able to avoid unwanted collisions. Furthermore, we will equip this device with a spraying system containing chemical disinfectant so that this device will be able to do its main function, which is to sanitize the public places. In addition, we plan to add more features such as rear camera or use LiDAR, light detection and ranging system, whether they follow the standard operating procedure or not. Furthermore, we plan to upgrade the structure of our prototype into a stronger and durable structure and use the actual size so it can perform at its finest. We will also establish its internal systems that will aid in the function of this device.
Okay, in conclusion, with the accomplishment of our project, we are able to innovate a new way of this disinfection procedure that is cost and time saving and could lower the risk of infection of COVID-19 to our frontliners. Hopefully, with the help of automated system as one of our weapons in fighting this microbial war, the chances of winning are increasing and it will ease the journey of this war. Thanks to our lecturer, friends and resourceful website we use as references. We managed to complete this project and explore more about Arduino throughout this project. Alright, thank you.